Investor opens savings account with no initial deposit that pays constant 4.5% annual force of interest. The investor deposits 700 at the end of every 6-month period for 20 years. The account balance immediately after last deposit is X. Determine which of the following is an equation of value that can be used to solve for X. So deposits happen every 6 months for 20 years. So that means they happen twice a year for 20 years. So there are 40 total deposits. And the annual force of interest is 4.5%. So the 6-month effective force of interest would be 4.5% divided by 2. And the present value of the deposits can be found by individually finding present value of all deposits. So the first one is happening 6 months from now, and all of them are 700 in amount. So the one that happens 6 months from now, so when you bring it back 6 months, so since the 6 months force of interest was 0.0225, so its value at time 0 would be 700 e to the minus 0.0225. Similarly, the second one, which happens in a year, will have 2 6-month periods between the year and time 0. So it's brought back through e to the negative 0.225 times negative 0.0225 times 2, and so on. The last one, the 40th deposit, is brought back through e to the negative 0.0225 times 40. And so in summation form, everything has a 700 with it, and it's e to the minus 0.0225 n, where n goes from 1 in the first term up to 40 in the last term. So that's the present value of the deposits. Now they're telling us that the final value is X. So now if we look at the answer choices, so 700 e to the minus 0.225 n from n equals 1 to 40, and that already tells us that it probably is choice E, but let's make sure that the right-hand side is also correct. So the left-hand side is basically the value of deposits at time 0. And the last one better be the balance at time 0. The balance after the last deposit is X. So that's the balance at time 20 years. So if you bring it back, from time 20 years to time 0, you multiply it by e to the negative 0.045 times 20, because now we can use the annual force of interest, since the time we are measuring is in years instead of the 6 months as was happening when we were considering the deposits. So this gives us e to the negative 0.9, and that was the right-hand side of 2, x e to the minus 0.9. So the equation of value was the present value of deposits, which was this left side, equals the present value of balance, and that was choice E.